Hello all, welcome to Talk GCSEs, and in this video we're going to look at nuclear fission and nuclear fusion. So two nuclear reactions that release huge amount of energy. Now these ideas come up regularly in GCSE Physics exams, especially higher tier questions, so where you're expected not just to define them but potentially to compare them, to evaluate their advantages and disadvantages. Now, by the end of this video, you should feel confident explaining what fission is, what fusion is, how they're different, and why one is used right now while the other is still being developed. Now, let's start by reminding ourselves what's actually inside an atom. Now, atoms and the nuclei. So when we talk about everything that we see around us, that is actually made up of atoms. Even though atoms are very tiny, they contain an enormous amount of energy. At the center of every atom is the nucleus, which contains protons and neutrons. So around the outside are electrons, but for nuclear physics, the electrons don't really matter. What's important in this is nuclear reactions involve changes in the nucleus, not chemical reactions. This is why nuclear reactions release far more energy than chemical reactions like burning fuel. When the nucleus changes, energy is released on a massive scale. Now, going on to nuclear fission. Nuclear fission is the splitting of a large unstable nucleus into two smaller nuclei. This is usually involved in very heavy elements such as uranium-235 or plutonium-239. So what happens is a neutron is fired at a large nucleus. When that neutron hits the nucleus, it becomes unstable. Because the nucleus is already very large, it can't hold itself together, so it splits apart. When the nucleus splits, two important things happen at the same time. First, a huge amount of energy is released, and second, more neutrons are released. And those extra neutrons are what led to something very important, which is called a chain reaction. Now, when we talk about chain reaction, the neutrons released during fission just don't disappear. They go on to hit other nuclei, causing them to split as well. Now, this creates a chain reaction, where one fission reaction triggers another fission and then another. Now, here's your key GCSE idea. In a nuclear power station, this chain reaction is carefully controlled. Control rods are used to absorb extra neutrons, slowing the reaction down, so basically the energy released is steady and safe. In contrast, in nuclear weapons, the chain reaction is uncontrolled and happens extremely quickly. But for GCSE exams, the focus is on electricity generation, not weapon. Now, using nuclear fission to generate electricity. So how do we actually use nuclear fission to generate electricity? The energy released during fission is used to heat water. That water turns into steam, which spins a turbine. The turbine then turns the generator, producing electricity, just like in other power plants. So, one big advantage is that nuclear power stations produce huge amount of electricity without releasing carbon dioxide during operations, which help reduce climate change. Now, there are a lot of disadvantages to nuclear fission as well. However, we need to think of the serious disadvantages, and exam questions often ask us to evaluate them. One major problem is radioactive waste. Now, this waste remains dangerous for thousands and thousands of years and must be stored safely. There are risks of accidents, although they are rare, but they do happen. And nuclear power stations are extremely expensive to build and decommission. So while fission is an effective way, it's not perfect. We need to also learn about fusion, nuclear fusion. Nuclear fusion is completely opposite of fission. Instead of splitting large nuclei, two small nuclei join together to form a larger nucleus. We do see fusions in stars and the sun, and there are quite a few advantages of nuclear fusion. If scientists can make fusion work, the advantages would be huge. Fusion produces vast amounts of energy, and fuel supply, hydrogen, is almost unlimited. It also produces no long-lasting radioactive waste, so there's no risk of runaway chain reactions like in fission. In our exam, we need to understand that we are able to define, we are able to compare, and evaluate both processes. So that's when you would feel fully prepared for GCSE Physics exam on nuclear energy. Now, if you've understood this video and you want to see more of them, don't forget to subscribe and share, guys. Thank you for listening to Talk GCSE.